This problem is a little bit tricky, but first, the aim of the question is actually to look for dy dx, because that means the gradient of the line OP, and we know that dy dx is defined as y prime over x prime, or we know that this is dy dt over dx dt. So our task to find dy dt, dx dt, and our job will be done. And x is defined as follow. I can write as follow, and I derive this with respect to t. And so when you derive this, you get this. I can rearrange as follow, and of course we say that after 3 seconds means the t is equivalent to 3. So when t is 3 and you perform the calculations, your dx dt, substituting t equals to 3 into this rational expression, you end up getting, well, negative 3 over 50. Now to derive y is a little bit tricky, so I'm going to review two things. First is this identity from Trigo. Tangent square theta is equal to secant square theta. That's number one. The other one, the idea is the idea of inverse of a function. If we have an inverse of a function of inverse, the composite function, this will be equivalent to x. So it's just like, you're going to left and going to right, of course you're back to the same spot. So this is for functions, something like that. Inverse of function will be same. You could also write this as f and then f inverse, and we'll still get x. Okay, so I try to be as clear as possible. This is part. So y is defined as the arctangent of t, or the inverse of tangent of operating on t. So what we can do is that we can write tangent y equal to t. Now if we derive this with respect to t, the whole thing with respect to t, you end up getting secant square y, and the right side is equivalent to 1. Now why I'm leaving a space right here is because this is actually an implicit function. So this one here, implicit function. So when you derive this with respect to time, I would have to add dy dt at the end. And so here we employ the first identity. Here secant square is 1 plus tangent square, and I end up getting 1 plus tangent square y, but the dy dt is y prime is equal to 1. So right here we need to be very careful is we are going to employ this particular concept, the inverse of a function, operate on the function itself, you get the x. So whatever you see here, it says 5, you see 5 here. Now, look at this tangent square y that we have here. This is really tangent of y to the power of 2. Now, y, if you try to understand that y is really arctangent of t, I mean the inverse of tangent of t. So that b means we are talking about the tangent of, and replacing y with the inverse of tangent of t. Now don't forget that the whole thing I put in brace is being squared. Now because of this idea, the inverse of inverse, you get here, and so this is tangent acting on the inverse of tangent, so you end up getting only t, but square because of the square here. So really, when you substitute this tangent square y with t square, you are really talking about 1 plus t square y prime equal to 1. This is from this equation, so we substitute the 1 in this darker color into this one here. So when t equals to 3, you will get y prime equals to 1 over 10, just solving it as a subject. And so finally your dy dx is really y prime divided by x prime. So y prime is 1 over 10, and x prime we have calculated already is negative 3 over 50, and the output, the final answer would be negative 5 over 3.